So in this video, we are going to discuss about how to create a binary tree, and we are going to implement this type of binary tree using linked representation. And as we know that there is another data structure in computing, that is linked list. So using the data structure, we are going to implement this binary tree that is linked representation. We are going to call it as a linked representation. Okay. So before creating a binary tree, we have to consider that from the root node, is there any left child or is there any right child? So using linked representation, we are going to implement this like this is the root node. Here left child and right child is null initially. So we are going to implement this using another data structure, that is Q, that is Q. First, suppose the address of this root node is 200. So we have inserted 200 into the Q. We have pushed in Q data structure. So now if we pop up this address and we take a temporary pointer, that is T. Now we are going to ask this root node that if there is left child or right child. See, there is left child and there is also a right child. So if there is right child, if there is left child, then we are going to take another temporary variable, another temporary pointer, that is temp. Using this temporary variable temp, or else we should call it P. Using this temporary variable, temporary pointer, that is P, we're going to create a new node. We're going to create a new node and insert that 5 into this new node. Suppose the memory address or address of this new node is 210. So we are going to push this address into our Q data structure. Now we are going to ask this root node, is there right child? See, there is right child. So we're going to create another new node using our temporary pointer P, and insert 4, and suppose the address of this new node 4 is 250, and we are going to insert this 250 into our Q data structure. Now remove this 210 address or pop up from our Q and take this pointer here, and again we are going to ask this node, is there any left child of this node? No, there is no left child, that is null. And we are going to join them from root node to 5, as 5 is the left child of 4. 7, and 4 is the right child of 7. So 7 left child and right child is not null, so we are going to join them like this. So there is no left child for 5, but there is right child 3. Again, take this temporary variable, temporary pointer p here, and create a new node and insert 3, and link them 5 and 3, because 3 is the right child of 5. Suppose the new node address is 300, and we are going to insert this 300 into our Q data structure. 300. Again, take this pointer here 250 and pop up, remove this from Q, and again ask for that is there left child. Yes, there is left child. So take this p pointer here and create a new node and insert 2. Suppose the new inserted node address is 350, and we are going to link them like this, and again ask is the right child, is the right child of 4? No, there is no right child. If there is no left child, if there is no right child, then we are going to assign them as negative value like -1. This is -1. -1. And for 5, there is no left child also. There is no left child. So we are going to assign them as -1. Now come to this node and take this pointer here, the address 300, remove this from Q and ask the same questions. Is the left child? Yes, there is left child. So take this pointer P here and create a new node and insert this 6 and link them. Suppose the address of this new node is 360. Insert this 360 in our Q data structure. Again ask, is the right child of 3? Yes, there is right child. So again, with the help of P pointer, we are going to create a new node 8, and the memory address or the address of this new node is suppose 380. We're going to insert 380 here, and now link them and take this pointer here and ask, is the left child or right child of 6? No, there is no left child or right child for 6, so we're going to assign them as -1, -1. Again 360 is cancelled. Take the variable here t and remove this 380 and ask the same question, is the left child or right child? No, there is no left child or right child of 8, so -1 and -1. Now our Q data structure is empty. So with this logic, we can create our binary tree exactly same like this, or else we can create any types of binary tree using this concept. So that's all in this video. In next video, we are going to write a function, write a program to implement this binary tree. We're going to discuss them. We're going to discuss the procedure in next video.